We've been doing a little bit of custom calculation for our attributes, and today we're going to do a little bit more of that. So last time, if you're following along with the series, we made a custom calculation class for a modifier magnitude calculation. And for the most part, that works for about 95% of calculations you're ever going to have to do. Today, however, we're going to go into the calculation executions, and I will warn you that with the basic setup that we have in our example game that we're working with here, I don't really have enough game design and enough different attributes to really show you an example of when this would be useful. I could put my own game up here, and as I explained about in the last video, I have this system here where the enemies have two bars. The blue bar is defense, the top bar, the green one, is HP. And as long as they have defense, I will always do 1 HP damage, but the moment they run out of defense, I will start properly doing health damage. And that is something I do through a custom calculation execution, because I need to both influence their defense bar, as you can see it regenerates after a certain amount of time, and their HP bar. And that's all based on my attack value as well, based on my weapons attack value on top of that, and based on the enemy's defense value as well. So there's a lot of different attributes that are getting added together, and then it influences two attributes at the end. So that is the reason that I'm using a execution here. For our example, we don't have anything that complicated in this project, so what we're going to do is we're going to increase the health during the regen and decrease the mana at the same time. Usually the way you would do this is to just add a second modifier. Just doing two modifiers, one to increase the health and one to decrease the mana. That would be the way you do that. But as I'm just doing this to show you as an example of how to set this up, we're going to do it through a custom calculation here. So I just removed the modifier that we have been using this entire time, and we're going to be making a custom execution calculation. So let's go into our C++ classes, and we'll make a new class. We'll go into all classes and use the gameplay effects execution calculation. And we'll call this calculation execution regen. Now, there's going to be a lot of boilerplate code for this. If you watched the last video and you thought there was a lot of setup for that, you're in for a bad time. So a lot of this is, if I remember it, if I don't, please shout at me in the comments and I will put it in there. A lot of these copy paste type of things, and maybe even some of the example stuff, I'm going to put in probably a pinned comment or down below in the description for you to copy and paste, because a lot of this is just stuff that you can throw into your project and just kind of not think about. But what we will need is we will need a constructor first and foremost. So we'll just add the name of our class as a function, and then we will need a function with a very long name, that being a virtual void execute implementation with parameters for const f gameplay effects custom execution parameters, reference execution parameters, and another one called f gameplay custom execution output, reference out execution output, and it's a const override again. So this is one of those things that's very long, you don't want to have to type it, so just copy paste it, it's fine. Let's make a definition for both of these, and now we get into the fun stuff, because where the modifier calculation that we did before had some stuff pre-set up very easily for us to capture attributes, we're going to need to do a fair bit of that ourselves. And this is something you can't really copy paste over that well, because it heavily depends on what attributes you need for this calculation. So let's start off by making ourselves a struct called damage capture. In here, we're going to declare the attributes that we need. So the way we do that is with a macro called declare attributes capture def for capture definition, and then you put in the attribute that you want to capture. So for us, we want to have health, we want to have max health, we want to have mana, And we don't really need max mana actually, because that's not really gonna be that relevant. You can hover over these to see what they do under the hood. Don't really worry about it, just type out this whole declare attribute blah 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 blah. Then this struct is going to need a constructor of its own. So let's make a damage capture constructor. And what it's saying here is actually correct. So let's walk through this. You can thank GitHub Copilot for making this a lot easier on me. So we have captured these attributes now, but now we need to define them. So the way we do that is with define attribute capture definition. And there you're going to pass in the attribute set that they are from, the attribute that we're working with, which is in this case health, whether or not it is the target or the source that we're looking at. In this case, we're applying it to ourselves, so it's the exact same thing, but because we're doing a regen spell, if we want to put it on something else, we want to concern ourselves only with the target. But for the mana, we're actually going to be concerning ourselves with the source. And I do believe that these last bulls are there for snapshotting. If you don't know what snapshotting is, go watch my last video. I'm not going to explain that again here. We do need to include the basic attribute set though, because we're now using stuff from it. So let's include. And at the end of the struct, you also need to put a semicolon so that it understands that this entire thing is a struct. And now that arrow up there disappears as well. Next, we need to get a getter for this struct. So we'll make a static damage capture reference, and we'll just call that get damage capture. And all that we'll do is make a static damage capture for damage capture, and then it will return that as a value. It's just simple, but we need a way to get all of this capture attribute stuff that we've made up there. Now, in the constructor for this calculation class is where we're going to start doing some fun stuff, because we need to have the relevant attributes to capture, and we need to add our damage capture and then all of the things that we have made definitions of. So Copilot, again, is just providing these for me. So what we do is relevant attributes to capture dot add, and then we use our get damage capture, which we have up here, that makes is a instance of this struct over here. And from there we can get our health definition, which is the thing that we made down here in this. So this is where we capture them. This is where we make the definitions. This function makes a static instance of it, and that we can access through this way. So you simply repeat this line of code and swap out your different definitions for every attribute that you need. I only need 3 of them at the moment, but you can make as many as you need. And the same thing goes for everything up here. If you need another attribute added, you just add it with a line like this and a line like that, and that's as easy as it is to add more attributes. Now we get into the execution implementation, which again needs a little bit of a boilerplate. So let's get into that. The first thing we want is a U ability system component pointer, and we'll call that one target ability system components. That one we will set equal to execution params dot get target ability system components. So exactly what Copilot is giving me. Then we'll make a actor pointer, and we'll call that target actor, which will be the target ability system component, get avatar actor, or null pointer. And then we'll do the same thing for the source. So source ability system component and the source actor. But that's not the end of it though, because we also need to add in our const f gameplay effect spec reference, which we will get from execution params get owning spec, which is exactly that line. Then we also need a gameplay tag container for the source tags and for the target tags. So let's make a const gameplay tag container for the source tags, which we can get from spec.capture source tags.get aggregated tags. And then we'll do the same thing for the target tags as well. Again, this is just boilerplate code that needs to happen in every single calculation that you do. And then the last bit of boilerplate that we need is the f aggregator evaluation parameters. to that, we will add those source tags and those target tags with evaluation parameters dot source tags equals the source tags that we just made and the target tags all the same. So once again, specifically like this bit of code, including probably the name of the entire function, I will put in the comments and or the description down below for you to just copy and paste, because this is tedious, and for the most part it's good to roughly understand what is going on here. If you don't quite understand everything that is going on here, it's going to make troubleshooting things, if they go wrong, a little bit harder. But don't beat yourself up too much over it, because you don't really interact with any of this code. This is just setting up stuff so the engine has the information that it needs to do its thing. After this is where we start doing our own code. So we make a float for our health, and then in our execution param, we can attempt calculate capture attribute magnitude, and then we can get the damage capture again, our health definition, in this case, the evaluation parameters, and then our health float. So what this is going to do is it's going to try to take the health attribute and put it into this float. So going forward, we can just use this float in our calculations, and we don't need to worry about using the attribute anymore. It's now just simply a number. And we'll do the same thing with our max health and with our mana. And here we can pretty much use the line that I used in the last video here, which is just we're going to set our amount of health that we can increase to just like this over here. So we'll make a float health to add, and this won't be the return value like it is with a magnitude calculation, because we are not doing anything for a magnitude, we're actually executing stuff. So we need to specifically add code to set the new value here. So in between here, you can do all of your fancy calculations and take in all of the attributes that you want and calculate them and multiply them and divide them and exponent them and whatever you want to do with them. Then when we actually get ready to do everything and apply everything to those attributes again, because remember, right now we're just working with numbers, with floats. We're not working directly on the attributes. So we need to set those attributes back to the new value. We'll use the out execution output, which is going to be another one of these very long strings of text. So bear with me here. We're going to go through this one thing at a time. So we'll use the add output modifier, and this will just work just the same way that using a modifier set to a addition operation does, but through code specifically. So we have the gameplay modifier evaluated data, in which we use the get damage capture dot our attribute property. So that's something that we don't define for ourselves, but through defining them with these macros, we get access to this health property. It just makes that for us. It's a little bit confusing using these macros, but I'm going to be real with you. It's going to be more confusing if we dive into what those macros actually do and how they work, because they're a mess. Then we have the eGameplay modifier operation, which can be additive in our case, but we can also make this division or max, multiplying or overriding, just like we are used to. And then we put in the float for the magnitude of that operation, so the amount of health that we're going to be adding. And then more or less the same way, we can use that same line of code here to say our mana property instead is going to be added to, but we'll add the negative health to add here. This still doesn't have clamping, so we can go into negative mana at this point. So what we really want to do is we want to also check, hey, do we still have mana? If not, we want to set both of those values to 0 or whatever, something like that. This isn't a course about basic programming. This isn't a course about like basic mathematical logic. So I'm not going to waste your time with all of that mumbo jumbo, which is kind of tangential to the topic that we're talking about here, and that is actually setting up the gameplay ability system stuff. I will also show you a quick alternative way to do this. So instead of using this like health to add that we're doing here, I'm going to remove that. What you can also do is, if you want to change something on either the source or the target, you can use that ability system component reference that we've made before, that pointer that's somewhere up here, one of these two. you can use those to, let's say in our case, the target ability system component. We can also use the apply mod to attribute. You can use the unsafe version if you're feeling very daring that particular day. And there we can do it with this way. We can get the attribute set and then a get attribute, whatever. In this case, it would be mana or actually health. We want to influence the health. So we want to say get health attributes. And then we can use the eGameplay mod operator for additive and then health to add. This is another way to do this. So if you hover over it, you will see the difference. It applies a in-place mod to a given attribute. This is correctly updated to the attributes aggregator, updates the attribute set properly, and invokes on-dirty callbacks. This does not invoke pre- and post-gameplay effect execute calls on the attribute set. This does no tag checking, application requirements, immunity, etc. No gameplay effect spec is created or is applied. This should only be used in cases where applying a real gameplay spec is too slow or not possible. So this is not a function that they really want you to use. This is not the way you really should be doing it. You shouldn't be getting used to it. But if for any reason this is giving you any trouble, this is an alternative way to do it. In one of my own calculations, I'll take my damaging for the enemy for my own game here. I don't remember exactly the issue that I had, I'm going to be honest with you here. But setting the defense lower on that enemy worked properly, and setting the HP lower on that worked properly. But when I attack, I also increase my own mana by the amount of damage that I do, and that just didn't want to work with the usual add output modifier. So I used this apply mod to attribute instead, and then it started to work. So do be aware that this is there as an alternative, but this is not the way you should be doing it. The add output modifier thing is the way that you should be changing your attributes at the end of your calculation. And now with all of that done, we should be able to compile and everything should work as expected. So we can go into our regen here, and in our executions we now should have the calculation execution for regen, and in here we can even put in like calculation modifiers still if we wanted to. So here we have the captured attributes that we have. So we have the health on the target, it shows you all of those, and then we can say, hey, actually the modifier operation for this, we want to do some stuff with specific attributes that we captured, and you can knock yourself out and do real good stuff even beyond what you've programmed in C++ on an individual effect basis, modifying those things. For right now, we're just going to use the calculation for the regen like this. So now if we enable our regen, we should see it again is working, counting up and stopping at our maximum HP of 120. Now, I do want to once again clarify, just to be sure, that the way we did it in the last video with the modifier magnitude calculations is for this specific use case the way you should go about doing it. You shouldn't overcomplicate things and use execution calculations for that. The only reason that I'm doing it here is because we don't really have a game here with like a lot of game design to it with the complexity that requires something like that. The example that I showed from my own code is a much better example of this. So let me walk you through that real quick. Like, this is my own code that I use for damage calculation toward enemies in my game, where I use the attributes for defense, health, damage, and strength. You might think these are the same, but I think damage is inherent to your level and strength is your weapon, or the other way around, one or the other. I get the mana and the max mana, and then in the capture definition here, of course, we do all that. Then we set up this simple function here, which just needs to exist. In the constructor, we go through all of those attributes as well. Then you see all of these code lines of code that I have here are the exact same in my own code. 100%. They don't need to change one single bit. And then we capture all of those attributes into floats. And then I do a little bit of math here to check how much mana I should add, depending on how much damage I'm dealing. Then how much damage am I dealing, taking into account the defense. Then we by default set the HP damage to 1, because that's the minimum it should do. If the damage to deal to the HP is more than 0, we add that, multiply it with strength, whatever, and then we output execution to 2 different things at once, that being the defense damage that we're doing to the defense bar, as you saw at the beginning of the video, and then the leftover damage will go into the HP bar damage. And I'll also add mana to my own character. So I'm influencing 3 different attributes here with 1 calculation class, and this is the kind of stuff that you should be using calculation classes for. Because all of these 3 attribute changes are dependent on each other as well. So that kind of complexity is where this more difficult version of custom calculations comes in. That said, I hope that has been a helpful video for you. It's a bit of a nightmare to get into specifically these calculation classes, but between the previous video and this one, that's pretty much the most mind-boggling thing about the gameplay ability system now covered. So we'll have a little bit of fun with it in the upcoming video or videos, and then we're slowly wrapping up toward the end, where you should really just go out and experiment on your own. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. And a special thanks to my Cave Digger tier Patreons, Sir J. Thomas,